Yeah, ladies and gentlemen, dear participants, welcome to our 11th event of our series Data Heroes, this time exceptionally in English due to our guest. I'm Gero Presser from Greenscape, and I'm very happy to guide you through our questions today. In our Data Heroes series, we regularly talk to people who have something to say about data topics, usually experts on certain aspects. And in this way, we want to show the breadth of the topic and at the same time put the people in the focus. Today, I'm very pleased to announce that we have Paul Moxon with us. Paul is Chief Evangelist at Denodo, and I'm pretty sure that we will find out what an evangelist actually does. In fact, that's one of my first questions. And the main focus of our talk today will be data virtualization. So let's start. Paul, thank you very much for taking the time and talking to us. Would you please introduce yourself?
Sure, and thank you for having me here as well, Gero. It's great to be here and chatting to you like this. So, in terms of myself, as Gero just said, my name is Paul Moxon. I am the Chief Evangelist at Denodo Technologies, and in this role, I work a lot with our customers, evangelizing, talking about data architectures and how data virtualization fits into their architectures.
Okay, that brings us back to this interesting term, evangelist. Could you please describe what an evangelist actually is and how did you become an evangelist?
Yes. So if you look at the definition of evangelist, it's an enthusiastic advocate. So you could think of other things. Elon Musk, for example, is an evangelist about traveling to Mars. He talks enthusiastically about going to Mars. I'm an evangelist about data virtualization, modern data architecture. So I'm passionate about data, the technology we use for that data, and delivering that data to the business so that they can take advantage of the data that the organization has got. So it's about believing in something, I suppose. It's believing in something and being passionate about this, in my case, the solution of how we solve our data challenges today.
So you believe in data virtualization. That's basically it, right? And you're enthusiastic about it. You want to spread the word, to talk about it.
Yes, absolutely. And it's not just about data virtualization, though. It's about data virtualization is one way of dealing with the challenges we have around data. So I talk about data architectures. I talk about data integration. So, for example, data mesh. Data mesh is one of the newer data architectures that we're hearing about. That's also a topic that I talk about and talk about very enthusiastically, very passionately, because it's something, again, I believe will help solve the data challenges that organizations have. Often I look at the way that companies or organizations are changing their data architectures, and lots of people talk about cloud data warehouses and things like that. And really, to me, that seems to be doing the same thing as we've done for the past 30 years and hoping that this time it will work. And that's when I get passionate about a different approach. That's the evangelist part of a different approach to changing something, I suppose.
Okay, very interesting. Thank you. You mentioned some very new things like data mesh. I think it's a quite modern data architecture. But regarding the core of data virtualization, I think, is this really something new? I think we talked about things like logical data warehouses 10 years, maybe 15 years ago. And at least in my understanding, that is basically what is possible with data virtualization. So why are you still passionate about it? Or is it such a long way to go to?
I mean, you're absolutely right. I mean, the term logical data warehouse was coined by one of the Gartner analysts probably about 15 years ago. You're probably right about that. It's about 10 or 15 years ago. And data virtualization was at the core of that logical data warehouse. So the technology, the idea of this logical semantic layer is not new. I think what's changed is that the technology is getting better. The technology in terms of the actual software that forms the data virtualization platform, as well as the underlying technology, it's getting better, and it's becoming real. It is real today. 10 years ago, we were probably in the infancy, but as it's matured, um, it just got better and better, and now it's in real productions in many organizations.
Mm-hmm. And you mentioned that the technology evolved, that we saw some breakthroughs. What are these major breakthroughs or major changes that make it possible today?
Um, some of it is around some of the technologies we've seen coming out of the Hadoop era. Hadoop has made it easier for people to gather huge amounts of data and then process that data. And then they say, well, how do I use and access that data? And that's where data virtualization comes in. But also things like AI, machine learning, the advanced analytics have become more readily available, and you can actually put those into use within the data virtualization platform to make it easier to optimize queries, to make it easier to manage the deployment, to make it easier to have recommendations to the users to help them understand and get the best out of that data. And all of that's what's happening in data virtualization.
Mm-hmm. Thank you so much. And I think we now talked mainly about the use case of the logical data warehouse, in a sense, to access data across the organization. Is this the core use case for data virtualization? Is it exclusively what data virtualization is being used for, or do you see other use cases as well?
The great thing about logical data warehouse as a conceptual architecture, as it were, is you can look at other architectures and say, well, that's the same as the logical data warehouse. So if we look at things like data fabrics, a data mesh, which I've mentioned before, any type of data integration really falls into this pattern. And an example of this is something that people don't usually associate with data virtualization, is something that Intel have done with the Denodo platform. And they've actually exposed all of their data through APIs, data as a service almost, exposing the data through REST APIs so that all of their downstream business processes, the supply chain, logistics, HR, payroll, are all driven through the data virtualization platform, but not analytical queries as we think of in logical data warehouse, more for that real-time operational business processes.
Mm-hmm. Well, that's a very interesting use case. Thank you very much. And this somehow gives me the impression that data virtualization is kind of a building block that you can use in different architectures for different use cases. Do you agree with this?
Absolutely. It is very much a fundamental building block for these types of architectures. And we've mentioned a couple of times already data mesh.
Mm.
At the heart of data mesh, even though it's a change in the way we manage our data, if you adopt a data mesh architecture, but at the heart of it, the foundation layer is actually a distributed data platform, which is what data virtualization is. So it is that foundation layer of many of these different architectures.
Okay. And one question that I was thinking about is in any data virtualization use case, you typically have something like an abstract semantic layer. You have to define what data you access. What is it actually? And this somehow has at least some overlap, I think, with the concept of a data catalog. What do you think? Are these things interchangeable or are they related to each other? What do you think about data catalog versus semantic layers?
Um, they are related, but they're different, and I think they serve different purposes. But they sort of do. You can combine them to make a very powerful data access layer, should we say? So the semantic layer, as you said, Gero, it's how we define the data, how we present the data. It's so we can have a consistent view of the data. We can, within the data virtualization layer, you can conform all of these different data stores. I can have client data stored in different repositories, different applications, and I can conform it to my definition of what a client is. And I can change keys on the fly within the data virtualization layer. So that's what I call the semantic layer. It's helping us define what the data should be and not how it's necessarily physically stored. Now, the catalog, in my opinion, layers on top of that semantic layer and allows the users to actually find the data using these standard definitions. So again, if we talk about that client example where I've got client data, I can go into the data catalog and I can search for client and I can find and look at the definition of a client, and then I can also go and access the actual data itself. So if you marry the two together, if you couple that semantic layer with data delivery with the data catalog, you have a very powerful data platform. So that they are, like you said, they are related. They're not the same. They're very related, and if they're coupled together, you get something that's very powerful for your users.
Okay, great. And if we have maybe this combination, the data catalog, the abstract semantic layer, and we can access data via data virtualization, then do we still need traditional data warehouses, or can the logical data warehouse or this architecture really replace this stuff that we're getting or that we're used to, I think?
Sorry, I'm going to go back to my evangelist thing. What you just said is heresy. Now, for 30 years or more, it's probably 30 years now, we've been using data warehouses. You don't suddenly come along one day and say, we're going to throw out our data warehouse. It's got 30 years worth of data in it. It's been driving reporting and analytics in the organization for those 30 years. Let's just throw it away and use this nice shiny tool. You don't do that. And I've worked with customers who have got the National Health Service in Scotland, who have got 40 plus years worth of data sets in their data warehouse. You don't just throw that away. So you complement it. You don't replace it. You complement it with data virtualization. Data virtualization will allow you to have your data in your data warehouse, but then combine that data with data coming from other sources, maybe a data lake, maybe from SaaS applications like Salesforce or ServiceNow, and combine all that in the data virtualization layer. But you certainly don't throw away your data warehouse.
Yeah, okay. So it complements the architecture and gives new opportunities. That makes sense.
Yes.
Thank you.
Yeah.
You mentioned SaaS application. That's also an interesting point, I think. At the beginning, I think some vendors at least had the idea that you bring all your data to one cloud and you have your whole architecture in this one cloud. However, it turned out that you mentioned Salesforce, for example. There's so many clouds nowadays. Probably most, at least large enterprises, have a multi-cloud environment and typically also several data warehouses. Can data virtualization help in this environment? Can it be like the central layer to access all these different systems and environments?
Yes, it can. The explosion of data in the past maybe 5 or 10 years or so has also almost required large companies, like you say, to have multiple cloud environments, multiple data warehouses. We've even worked with a government agency in the United Kingdom that had 13 data lakes. So it's just a total explosion of data in all these different repositories. The challenge then for the user, somebody trying to get to this data and make use of this data, is where is the data? And this is where data virtualization can come into play. We have this concept called multi-location architecture. And the idea is, instead of trying to copy all of your data as a central repository, you leave it where it is, but you put the data virtualization layer, platform instances co-located with the data, maybe in the different clouds, the different regions, the different data centers, etc. And then those instances are connected together. And the data virtualization platform can do intelligent routing, so that if I want to access to the data virtualization platform instance that is co-located with that actually data repository, get the data and bring it back to me. An example of this is an Australian mining company called BHP, Broken Hills Proprietary. They're based in Western Australia, but they have mining operations in Chile, in Brazil, in Canada. They have oil and gas interests in the United States and in North Africa. And they have these data centers around the world, plus data up in different cloud regions on AWS. And they use data virtualization to connect everything into one logical platform, so that if I'm in Perth, Australia, I can connect to this logical data layer and access data from Santiago in Chile. And I don't know where the data is. I just know, oh, it's there and I can use it.
Okay, very convincing. I'm very impressed that these architectures really exist in real life, because I was thinking about your job title, evangelist, preaching about technology in a sense. I think real world preachers typically talk about gods, for example, but only very few have really seen any gods. It's more like a vision or something that you don't achieve. So this kind of architecture, including data virtualization, is really in place at some customers, and it's up and running. It's not just a vision, but it's possible to implement these these architectures, right?
Absolutely, it is really working. And even if you look at the Gartner hype cycle, data virtualization and the concept of a logical data warehouse is in what they call the plateau of productivity. That means to me that it's gone mainstream, it's accepted, it's tried, it's tested, it's working.
Okay. And I think you mentioned before that the technology is getting better and better, and it's now ready. 10 years ago, it maybe was not sophisticated enough. But what do you think will happen in the, let's say, near future? What will change? What will become possible tomorrow, maybe, with this technology?
Our data is always going to be distributed. And I think you mentioned previously about large organizations having multiple clouds and multiple data warehouses. I think companies, organizations, and data architects, more in particular, are realizing that their data is going to be distributed. They can't consolidate it into a single repository, this single data lake. So as the technology within data virtualization gets better, it's becoming more intelligent, it's becoming smarter, it's automating a lot of the mundane tasks. So it's allowing people to make better use of the data. The machine learning algorithms are improving how people can find and access the data. It's got recommendation engines in there, so that people can understand that, okay, all my colleagues are using this data set, I ought to use that data set as well. And as we go through, you're actually, especially in Europe, we're seeing more and more privacy legislation and governance issues. coming out. So being able to manage and control, being this central access layer, it's a logical access layer, but it's a centrally managed access layer. Data virtualization helps you with all these types of things, compliance with privacy regulations and things like that.
Well, that's a very important and strong point, I think. So when data virtualization is really this central managed access layer through which everything passes, is it then possible to guarantee who is allowed to access what data and also to monitor who really accessed what data? I think that's a very important point with respect to data governance, etc.
It is. It's in today's environment, the risks of the wrong people accessing certain data. It's not just regulatory risks. It's also the reputation of the organization, and having this one place where you can monitor and control who is accessing the data, it is going to be very important because you can prove compliance. I remember talking to one of our customers about this. They have literally thousands of databases in different data centers around the world. And they were struggling to prove that they would adhere into regulatory compliance, organizational compliance, and contractual compliance because they had data for lots of different customers, and they had to keep these sort of what we call the Chinese walls between each customer's data, and they had to prove to the customers that nobody else could see their data. And it was very, very difficult when you've got to go to thousands of databases and show that you comply with all of these constraints. By having data virtualization, they were actually able to say, look, everybody accesses data through this data layer. And I can prove to you that nobody can access your data other than the people who've got approval, the privileges to access your data. So this is going to be very important, especially when you move to distributed systems like data mesh, etc. You don't want to lose control of the platform itself. Data mesh allows the domains, as they call them, to build their own data products, but you need this centralized control of things like security, governance, etc. Because without that, you're lost.
Yeah, I can imagine that it plays an important role in this architecture as well, but probably in every architecture, since this role monitoring data access is very, very important, and having
Yes.
rights management. Great, thank you. Then we always try to have also some look into the future, and you have many insights in the market. You're very familiar with everything that's going around with data virtualization. What do you think is the next big thing regarding architectures or data virtualization in particular? What will we see?
Certainly, if we think about data management, data integration, I think we're starting to see a convergence of different types of integration. The data access layer, the classic data access layers like data virtualization, but also combining that with API platforms which expose application data through APIs. They're converging into one. I think the analysts call it a hybrid integration platform. So we'll see convergence as being one of the next big things. So instead of having to have a data access layer, then an API management layer, it will all be one platform, this hybrid data platform. And also at the moment, we've got this concept of a data catalog, collaboration. I know they're governance tools as well, but they will sort of be subsumed into this hybrid data platform as well. Instead of being more standalone, they will be part of the whole data management, data delivery layer in a single platform, a single tool.
Thank you. That's an interesting outlook on the whole market. And in a way, this fits very well with the last question that I have. In fact, it's a more or less a twofold question. And it's about Denodo, actually. Can you explain Denodo's history? Because I was wondering, 20 years ago, you already focused on data virtualization, and this seems to be quite kind of impossible. The technology was not really ready at that time. And the second part of the question, Denodo is very, very focused on data virtualization. Do you think this is a strength, or is it also a limitation because you don't can go into every direction because of this strong focus? What do you think about this?
So it was two parts. Like you said, Denodo for more than 20 years now, we've been focused on data virtualization, and in some ways we are waiting for the market to catch up to the idea of having distributed data, and that's happened maybe in the last 10 years, and that's where Denodo's really grown very strongly. So we had great technology, but the market wasn't ready for it. Now the market is ready for it, and we're seeing people adopting data fabrics, data meshes, and data virtualization being the underpinning. Now, in terms of is our single focus a strength or is it limiting? It really is our strength, because it means that we have got this very, very solid, well productized, certainly tried and tested underpinning technology, underpinning on which we can build other things. 10 years ago, we didn't have a data catalog. Now we have a data catalog that's built into the data virtualization platform. 10 years ago, we didn't have global security policies based on tagging your data. We do have that now. So the product's continuing to evolve. It's going beyond just the narrow band of data virtualization, but that data virtualization technology provides the core foundation to allow us to move into these other areas. So we now say we're a data management and data integration company because we're more than just data virtualization, but that's still our foundation.
Okay, makes sense. Thank you very much. This was very interesting, also because we're a partner of Denodo and always interested to see in which direction you're moving. Yeah, Paul, thank you. Wonderful evangelist today, I think. We learned quite a lot about the possibilities of data virtualization, the market, the perspective. Many thanks to all participants today. Thanks for taking this time, and hope to see you again next time. Yeah, that's it for today. Thank you, Paul. Bye-bye.
Thank you.